Hello students, welcome back to Right Foundation. So today we are going to solve the numericals in the moment of inertia concept. So in the last class we have completed the concept based questions. So now exercise 1 problem. So first problem we'll see here now. So two copper circular discs of same thickness, the diameter of A is twice the B. The moment of inertia of A compared to that of moment of inertia of B there, okay. So here two circular discs are there of same thickness. Okay. Exercise 1. So first problem. So two circular discs of copper circular disc. So we know that the moment of inertia of a circular disc, moment of inertia of a circular disc about the moment of inertia of the circular disc about the diameter. So about the its own axis there. Okay. So that is mr square by 2 it is there, no. So uniform circular disc mr square by 2. So then moment of inertia of the two bodies. Let us consider the moment of inertia of a circular disc of copper disc, first disc A. So we can write here mRA square by 2. They have the same thickness, means mass will be same there 2. And for the moment of inertia of that body, it is mRB square by 2 will get there here. Same thickness, means the mass will be distributed same there. Now here they given there diameter of A is twice that of the diameter of B. So then here what it will happen there? Diameter is nothing but so radius. So here we can add there r by 2 is equals to here RA by 2, here 2 times of here RB by 2 we can add there RB by 2. So this also then it is 2 times. So from this we can write here RA is twice that of 2 times of RB. Okay, the moment of inertia. So then the moment of inertia of A it will become there. Moment of inertia of A. So we can write here it will be so mRA square, mR square by 2 we can write here mRA square. So now here IB is equals to so mRB square by 2 we can write there mRB square by 2. Okay. So the moment of inertia of the circular disc, moment of inertia of the circular disc, the diameter of the A is twice that of B. The moment of inertia of A, moment of inertia of A as compared to that of B is. So here we will take there the moment of inertia of the circular disc. We have the formula now. So uniform circular discs. We have the list, in that list circular disc formula we have there. The moment of inertia of a circular disc is, so about its axis there we can write there mr square by 2 there. So about the diameter, suppose if you take here they have given their diameter, no, if you take the diameter there, so it can be written as mr square mRA square by, so we can write here about the diameter it can be written as here 4 mr square by 4. So here IB can be written as here, so that is mRB square by 4 we can write there. Okay. So about the diameter they ask, no, so then we can write here about the diameter we will take there here. The moment of inertia of about the diameter is mr square by 4, that we will take here now. So here the diameter of first one, the diameter of A is twice that of diameter. So then our diameter radius of the first disc is twice that of the radius of the second. So now if you substitute here now, so if you write this one mr square by 4, so now IA can be written as here m into this we can write here 4 times of this one RB square by 4 we can write there. So here IB is equals to m into so RB square we can add here RB square by 4 it will be 4. Now here we can add there mr square Rb by 4. Now here the moment of inertia of this A. So it is 4 times of moment of inertia of B. No? Okay, no? So moment of inertia of the B. Diameter. So sorry, here diameter is nothing but 2 times of the, no? So here we can write like this. We'll do like this. Actually here this one we'll see here. So diameter is nothing but here 2 times of Ra. So is equals here 2 into 2 times of Rb we can add there. 2 times of Rb. So dB is nothing but, diameter is nothing but 2 times of radius. Okay. So 2 times of radius we can add there. So from that also we can get there what? So dA is equals to 2 times of Ra we can add there, that is 2 times of Rb. So we will get there same there. So now the moment of inertia of A, it is 4 times of this mr square by 4 we can add here. So that is Ib we can add here, Ib. So now the answer we can add here, the moment of inertia of A, it will be 4 times larger than that of B. 4 times larger than that of B there here. Okay, this one. Ra is equals to this one. So now the moment of inertia of first disk is larger than that of 4 times larger than that of moment of inertia of B. Okay, option 2 we can add here, option 2. So next second one. Second one, consider a light rod with heavy mass particle at its ends. Let AB be a line perpendicular to the rod as shown in the figure there. So here we'll see the next problem. It's clear now this one? So next one we'll see here. Second one. Second solution. So here the diagram is given there. Consider a light rod with 2 heavy mass particles at its ends. AB, capital AB, BA, a line perpendicular to the ends as shown in the figure. So what is the moment of inertia of the system about the AB? Okay. So here a light rod is there, and at the ends of this rod there are 2 masses are kept there. So that mass M1 and M2. So here M1 and M2. And there is a perpendicular line is there. About this it is 2 masses are rotating there. So consider this is the R1 distance, and here the diagram is given here, it is R2 distance. Means from here to here it is R1, and from here to here it is R2 distance. So it will be the R2 distance. The moment of inertia about that axis. The moment of inertia about the axis we should find out there. So what can we write there? Moment of inertia. So moment of inertia from this particle it can be written as here. Total I we can write here I1 plus I2, no? I1 plus I2 we can add there. I1 is nothing but M1 into R1 square we can add there. Mass of the particle and perpendicular distance from the axis of rotation. This is a capital AB. This is a capital AB we can add there. Okay. So M1 R1 square we can write, and plus here this one M2 R2 square. M2 R2 square we can add there. So therefore the moment of inertia I is equals to, so M1 R1 square plus M2 R2 square we can add there. M2 R2 square. This is the moment of inertia about the line AB. The moment of inertia about the line AB. So M1 R1 square plus M2 R2 square we can add there. This is the first option. Option 1. Okay. Now next one we'll see there. 3 particles of masses 1 gram, 2 gram and 83 gram are at centimeters, are at 1 centimeter, 2 centimeter, 8.3 centimeter from the axis of rotation respectively. Then the moment of inertia of the system and the radius of the gyration of the system respectively are dash. Okay, so we should find out the 3 particles of the system. Okay, there are 3 masses are given here in the question. Third solution. There are 3 masses of the particles are given. So that is, so here mass of the particle M1. M1 is equals to 1 gram is given, and M1 is 1 gram, and M2 is equals to 2 grams is given there. M2 is 2 grams. And next M3 is given there 83 grams. 83 grams. And M1 particle is at a distance of 1 centimeter from the axis of rotation. This is a 1 centimeter. And R2 is at a distance of how much there? 2 centimeters. And R3 is at a distance of 8.3 centimeters is given there. This is a 2 centimeters. They are the distances, perpendicular distances from the axis of rotation. Then the moment of inertia of the system and the radius of gyration of the system of particles respectively. Okay. So we should find out the moment of inertia of the system there. So then here we can write there. There all are the moment of inertia of the individual particles. So we can write here I is equals to I1 plus I2 plus I3. We can write here I3. Then here we can write there. So M1 R1 square plus M2 R2 square plus M3 R3 square. We can write M3 R3 square. So here M1 how much there? So 1 gram. And here the options are given there gram centimeter square. Okay, gram centimeter square is given there. So we can write as usual. We should take there. No need to convert that all the numerical values into the SI system. All the answers are given in the CJ system only. So they are asking here gram per centimeter square and the centimeter square. They are asking there centimeter. So first one M1 into here M1. So 1 whole square we can write there. M2 is 2 into here 2 square we can write here. And 83 into 8.3 whole square we can write there. 8.3 whole square. Okay. So then what can I write here? This is a 1 only here. 1 plus this is a 4 plus 8 will be there here. 2 square means 4, 8 to 2, 8 plus here 83 into so 8.3 whole square. 8.3 whole square means so 8.3 into 8.3 we can write here. This is a 9 and it is 24. So 24, 16, 18 will be there here. Sorry, 64 plus so 64, 66 it will be there. 66 means 9 and here 8, so 8, 6. So here we will get there 68.89 and here we should add there 9 now, 9.00. So we will get there 89 and here it is 17. So 77.89. So 77.89 will be the 70 system of, it is the moment of inertia of the body there. Moment of inertia of the body we can add there. Okay, moment of inertia of the particles. 3 particles of masses 1 gram, 2 gram, 83 gram are at a distance of 1 centimeter, 2 centimeter, 8.3 centimeter from the axis of rotation respectively. Then the moment of inertia of the system and radius of gyration of the system respectively. Okay. So it has been given here like this. 3 particles are. Then the total moment of inertia it can be written as here. So it is this one 8.3 is there, no? 8.3. So 8.3 M3 into 8.3 whole square we can add that. M3 square. So that is 8.3 only. 8.3 into 8.3. So here we should do this one. Here we got this. So now 83 has to be multiplied again here. 83 grams. So if you multiply 83 grams, how much? Okay, what will you get here now? 83 grams, no? So if you multiply here 83 grams, so we will be get here the, so multiply here 83. So 83 if you multiply here, so 68.87. So here 83 if you multiply there, how much we get there here? That is the, so it has been given now 83 grams are at a distance of, okay, gram per centimeter, 83 centimeter square. Okay. So here 1 will come there, and here 4 square into 2, 8 will come there, and 83. M3 into R3 square. M3 into R3 square. So multiply here now 83 multiply with 83. So this will get here 27 and 24 26. So 24 26 and 18 will get here, and this one here 72 and 64 plus 7 71 will get here, and 64 plus 7 71, and here this one 64 plus 48 plus 7 48 plus 7 55 will get there, 55. So we'll get it here, how much we get there? This is a 7 8 7 9. So this will be here, it is a 6 5. Okay. So if we write here, this is this one. After 2 decimal points here it will be there, no? Then here 2 decimal points will be here, it may come there. So it may come there. So here it would be this is not 83 grams, it is 0.83 should be there here. So this should be the 0.83 grams, and so here we will get it as here 56. So then 56.9787. So here it will be 9 will come there. So 9.00. So we'll get there here 7800 7, and here we'll get there here. This is a so 65 points. So we'll get approximately here 66 will get there, 66. So now here that is so it changes, this is 0.8 grams and 8.3 centimeters. So we'll get that value as 65.9, that is approximately equal to 66 gram centimeter square, 66 gram centimeter square. So therefore the total moment of inertia I is equals to 66 gram centimeter square. So this is a moment of inertia. That is a moment of inertia now. The now next one we should find out the radius of gyration. Radius of gyration there. Radius of gyration. So radius of gyration, how can you find out there? So we have the formula of the radius of gyration. Okay. So this everything is the. Now we'll see there radius of gyration. So radius of gyration we can take here the formula of radius of gyration. So we can write here that is a k. So k is equals to square root of, root means square value of the perpendicular distances, that is r1 square here, r1 square plus r2 square plus r3 square divided by here we can add there 3 number of. So then here what can we add there here? So 1 square plus 2 square plus here 8.3 whole square divided by 3 we can add there here. So we will get it here. This is a 1 plus 4 plus here 68.89 we got there, 68.89. Okay. So divided by 3 will get here. So root of this one 5 will come here. 5 means 5 73.89 73.89. So divided by 3. Divided by 3 means how much we get there? So here it is 3 ones are, 3 twos are, 3 sevens are. 3 twos are 6. 6 means 1. So here 4s are 12. 3 4s are 12. So 1 will be remain here. So it is 0.6 and here 3s are. So we'll get it here. So square root of 24.63 we can add that, 24.63. So that is a centimeter square. Now will come here centimeter root of that. So root of 24.63 24.63. So root of that value, how much you get there? Root of that value. So it would be 25. 25 means it is a 5 will come there. 24 means it is approximately, we will get it here 4.5 it may be. So 4.5 will get there. Okay. So 4.5 centimeters will come there. So this is a radius of gyration. It will be the radius of gyration. So the radius of gyration formula is this one. Root means square value of the perpendicular distances from of the each and every particle from the axis of rotation. So here r1 square plus r2 square plus r3 square we can write here. So they have given here 1 square plus 2 square plus 8.3 whole square. So from that we will get it there. So here 8.3 whole square, how much we got there? That only no? 8.38. Yes, 68.89 only. So we'll get it here 68.89. So if you add there, you will get that value. So that is, so 4.9 centimeters will get there. That is the radius of gyration. Radius of gyration there. Okay. Next problem we'll see here. So I is the moment of inertia of a thin square plate about an axis passing through opposite corner of plate. The moment of inertia of the same plate about an axis perpendicular to the plane of the plate and passes through its center. Okay. So here it is given there square plate. Moment of inertia of the square plate. So moment of inertia of the square plate passing through its center, perpendicular to its plane there. Okay. So about an axis passing through its, I will be the moment of inertia of a thin square plate about an axis passing through opposite corner of a plate. So moment of inertia of the square plate about an axis passing through its center there. So that square plate nothing but will take the diameter disc only. Okay.